I'm Bill Hubsher.
And I'm Lori Meggs. On this episode of Focus on Marshall, we'll give you a rare behind-the-scenes look at how Marshall Space Flight Center helps to ensure and support safe space shuttle launches.
But first, we're going to learn more about Marshall's role in NASA's mission to study the sun. We're here with Dr. John Davis, who is the manager of the Space Science Office, but he also has another title as the principal investigator of the SUMI mission. First, Dr. Davis, if you would, let's start with your first title. What is the Space Science Office responsible for?
Well, at Marshall Space Flight Center, we're mostly a propulsion center, but we also have a science arm. And we have a broad range of activities covering astrophysics, solar and space physics, and now a little bit of planetary physics.
Let's concentrate a little bit now on the solar side of that particular mission. In fact, you've got a very big project working on right now, the SUMI project. What does SUMI stand for?
SUMI is the Solar Ultraviolet Magnetograph Instrument, which is an instrument telescope and a spectrograph at the same time that will look and take data of a region of the sun that is impossible to see from the ground. But it's a region that has a lot of interest because it is where the gas pressure in the solar atmosphere and the magnetic field pressure are changed from being dominated by the plasma to being dominated by the magnetic field. And that can create an extremely interesting set of physical problems. And it's probably where the energy that's released in solar flares comes from. And the energy that's released in solar flares can drive a lot of the effects of space weather that can affect both the Earth to some extent, but especially the spacecraft that are flying outside the protection of the Earth's atmosphere.
So how does SUMI and your work with the Space Science Office fit into NASA's overall mission?
Well, SUMI is a sounding rocket experiment. And one of the reasons why one has a sounding rocket program is one tries out new ideas to see if they actually work, to see if you can build the instrumentation, and then, and if what you believe is happening actually you see happening on the sun, then you would propose this for a larger, more expensive mission. But we're doing the groundbreaking work to demonstrate that we're capable of making these measurements.
Well, Dr. Davis, thanks very much for your time. We're going to learn a little bit more about SUMI right now with Lori.
I'm here now with Jonathan Certain, and he is the project scientist for SUMI. And Jonathan, tell us about this hardware we see behind us.
Okay, SUMI is a telescope designed to take images of the sun at about 3,000 and 5,000 kilometers. The images collected will tell us a significant amount about the sun's magnetic field, how it extends out into space, and what impacts this magnetic field may have on energy transfer mechanisms from the sun's surface out into the solar atmosphere.
And there are lots of other instruments out there in space looking at the sun, but this does something unique. What will we learn from this?
Well, in particular, SUMI is designed to directly measure the sun's magnetic field. In particular, at the two altitudes I mentioned, 3,000 and 5,000 kilometers, this direct measurement has never been made before. Through a unique development of technology and our integration techniques, we've actually learned how to make these measurements and believe that these first-of-a-kind measurements will tell us something definitive about the way the magnetic field extends out into the sun's atmosphere.
And why is that important to us here on Earth?
Well, the manner in which energy is transferred from the sun's interior out into the atmosphere heats the solar atmosphere and generates the solar wind is as yet an unanswered question. Understanding this process will help us understand the space weather in which the Earth lives, satellites must operate, and astronauts must exist for us to have our extended missions NASA has planned in the future.
Let's talk about the mission in particular. Only 30 minutes. You guys have worked many, many years on this, I know, but that's a quick mission, right?
It is. In particular, we'll only get about 5 minutes of data. However, through years of preparation and planning, we believe we'll be successful in that 5-minute duration. And SUMI is a test concept instrument, and so taking this quick flight allows us to return SUMI to our lab, redefine the manner in which she'll collect that data, refine our processes, and hopefully relaunch her again in the future, prove the concepts work, and take those concept designs and the information we learn and launch an extended mission on a satellite sometime within the next decade.
We wish you lots of luck. Thanks.
Thank you.
I'm here now with DK Hall, and he is the Deputy Manager for Shuttle Propulsion Systems Engineering and Integration here at the HOSC. And DK, tell me exactly what HOSC stands for.
Okay, HOSC is the Huntsville Operations Support Center. And this room that we're in is part of the HOSC, and it is the Shuttle Engineering Support Center. And it does exactly what its name says. We are the down and in reach for the managers who are supporting the launch from the Cape to get to their project teams and their engineering teams to work any particular engineering issue, pull data, history, whatever we need on launch day comes through this room.
It's a vital role. You guys actually monitor all of the propulsion elements. Tell me exactly what you're looking at, for example.
Okay, on a typical day, each of the 4 elements have areas in this room that they're assigned, where we have the main engine group, external tank, reusable solid rocket booster, and the reusable solid rocket motor teams. And each team has a certain set of parameters they look for, whether it's temperatures, pressures in the system, voltages, things like that, turbine speeds. They're all able to access that data through our database here.
And you guys are actually the eyes and ears for managers that are already at the Cape on launch day, right?
Correct. Our 4 element managers and our shuttle project manager are mission management team members, and they are in the firing room 1 at the Cape. And when they have a limited set of data that they can process, they're only one person, and they can turn back to their team here in this room and really dig down into any particular issue if these guys are the eyes and ears for them, and they're watching for anything that's going out of family or any parameter that is trending high or low. They can notify the manager at the Cape. They're watching that situation. They can go down, dig previous flight history, find out what we can expect, or this situation will clear itself, this one we need to watch, and find out what's in bounds, and we ensure a safe launch that way.
And you're kind of funneling all that. You're actually at the Cape on launch day, but there is a manager here too, right?
Yes, we have the HOSC shuttle manager here that works directly for the shuttle propulsion manager there at the Cape, and he's the quarterback for this room.
All right, I think Bill's with him now.
We're here now with Scott Schutzenhofer, who is the HOSC shuttle manager. And Scott, as they mentioned, you're the quarterback of this team. Tell us a little bit about what it is you do.
Well, it's a multifunctional task. We got our Marshall shuttle manager down at KSC. Our job is to make sure that he gets all the data he needs, and what we have is all these 80-something people back behind us that work to give him data. They'll feed the data up through me. I'll communicate exactly what the problem is to him so he can make a decision on launch day.
Now, on launch day, you said you had about 80-some-odd engineers. We wouldn't even be able to fit in here. But it looks like you have a little bit of a lighter team here today. Why is that?
Well, today we're having a launch sim. We have a launch sim about once a month, and we have these folks come in here and we feed them problems they're typical not used to seeing, and see how they act and react to them, so how they communicate with their line managers so they can get the problem solved. It's a practice run, kind of like in a baseball team would do. You practice every day for baseball for a game once a week.
All right, now you obviously can't do this by yourself, so you've got some assistants here on your management team. Yeah. What are some of these gentlemen doing back here?
We got Mac Tankersley. He takes care of our PC Go. We've got thousands and thousands of data screens, and all these folks we have in this cadre look at data, and he'll take it. If they have any issues, sometimes we have data dropouts, and he'll take and look at make sure that they're getting the data they need. And then we have Jason Romines, who takes care of all of our voice communication. You got all these folks that are communicating. They're looking at data. They don't have time to worry about if their headsets drop out. A lot of times we have different problems with voice communication. He'll go troubleshoot all the voice communication problems.
Wow, I know they must be jumping then on launch day as well. So, Scott, tell me, why don't we have, I guess, a lot of these people down at the Cape on launch day?
Well, you got 80 people here. It's easier to have everybody. We're all on call. We're almost kind of like a fireman. We're on call. If they need us here, we can be in here within 30 minutes to troubleshoot any type of problem. On a launch day, if we have a scrub, everybody goes home. We can turn around and come right back. You get 80-something people traveling back and forth, and logistics just become a nightmare. We got these people. We got a standing army right here at Marshall Space Flight Center.
And you guys work very hard, and we appreciate it. Thanks a lot, Scott.
Sure.
For information on these and other NASA programs and to see archived editions of Focus on Marshall, visit www.nasa.gov.